All right. Today we have Alison Mote, and this is one of the talks from our JSG Alumni series. So Alison received her master's degree from UT in 2004, and now she's at the Office of Strategy and Policy running the Texas OnRamps program. So I'll let Alison take it away, and we kind of chatted earlier about the preference for questions in this talk, and if you have a question, you don't necessarily need to wait until the end if you don't want to, so you can go ahead and raise your hand, and we can address it during the conference as well. All right, take it away, Alison.
All right, thank you so much. I'm really excited to be here. Thank you everyone for joining me. I turned on my chat pod, so if you have questions, you can type them in the chat, or of course unmute yourself as we go. But today I'm going to talk about my work with the OnRamps program, where I'm the course manager for the Geoscience dual enrollment course. So as an overview of my talk, first I'll talk to you a little bit about OnRamps and our mission. Oops. And then I'll talk to you about the Earth, Wind, and Fire class and kind of give you an overview of some of the pedagogies we use in the course to engage students. And I'll talk about how we prepare instructors to teach our courses and some of the Jackson School community involvement that we've been very fortunate to have in participation with the course. And then finally, our impact. So a little bit of the numbers behind the OnRamps Geoscience program. Okay, so I thought I would start with a question for you all to get a little bit of audience participation here. So in your opinion, what are the two greatest challenges facing geoscience education today? And we're going to use this Mentimeter app. So if you are on a device, you can use your phone or computer. Well, everyone's on a device, I suppose. You'll go to www.menti.com. and you'll type in this code. You don't have to enter any of your personal information, but I'll give you a few minutes to tell me what you think are some challenges facing geoscience education today. And these will be anonymous when they start to pop up. So if you're just joining us, you can participate in my little interactive portion here. If you go to www.menti.com, it's listed at the top, and type in this code and tell me what you think are the two greatest challenges facing geoscience education today. Ooh. All right, this is great. So a lot of these things I'm going to talk to you about today, and of course we'll come back to them. In this talk, I encourage you to ask questions and provide your feedback. But definitely we'll be talking about diversity and how the OnRamps program seeks to engage a more diverse population. Teaching climate is definitely a challenge, and broadening participation in the geosciences is something that we're also looking for. So I see a lot of broadening in scope there, which is great. And career paths is an interesting addition. So I'm excited to hear kind of y'all's feedback as we go through this talk as well. So I'll come back to this in a little bit if you want to keep adding to it. And then Dana asked an interesting question in the chat pod about resources, if that's meant to be natural resources or resources as in access to things for students. So that's a good comment. So if you would like to respond to that, I encourage you to do so in the chat pod. So we are going to be talking about a lot of the things that you guys mentioned today. And I wanted to start, since this is part of the alumni series and talking about my path to geoscience education. So I am a proud alum of the Jackson School. I got my master's in 2004. And in my time at the Jackson School, I was a TA, and Dr. Jay Banner was pretty influential on my desire to become an educator, a geoscience educator. And also while I was a student in the Jackson School, Dr. Mosher was on some committees to kind of look at the earth and space science education in high schools. And at the time, the TEKS, so the Texas Essential Knowledge and Skills for the Earth and Space Science, a newly developed Earth and Space Science course, were being developed. So all of these things kind of, I was always interested in teaching, and things that were happening at the Jackson School kind of also pushed me towards a path in education. After I graduated, I had the pleasure of working in the CT lab in the basement. I don't know if there's any CT lab fans out there, but I am definitely a fan of the CT lab. So gained a lot of valuable research skills in the CT lab. And while I was there, I decided that I did indeed want to pursue a path in education. I see some thumbs up there. So I'm not sure if Rich Ketchum is here today or not, but huge kudos to that group. I love those guys. So while I was working in a CT lab, I joined a program called the Texas Teaching Fellows, which is an offshoot of the New Teacher Project. They are not in Texas anymore. They certify high needs subject areas in kind of urban districts. So I pursued my alternative certification. And while I was getting certified, I started teaching. So I had a probationary certificate. And of course, I was really excited to teach Earth and Space Science. It was a newly developed science course. And I wanted to, engage students in my love and passion for earth sciences. And of course, when I started teaching at Travis High School in 2007, I taught physics and chemistry and no earth and space science. But eventually, after pushing for it, we did bring on earth and space science. I also taught AP environmental science. And then in my last few years teaching, actually my last year teaching at the Ann Richards School here in Austin, I taught the OnRamps geoscience course in its pilot year. And while I was teaching, I was very fortunate to become involved with the Texas Revolution, which was a teacher professional development program that was spearheaded by Kathy Ellens in the Institute. And this program really inspired myself and a lot of other earth science educators, and still does today. So I still work with lots of teachers that I met in this program. And what was wonderful about it, and I know probably a lot of you are familiar with this project, but it really gave high school teachers and middle school teachers the tools to engage students in activities using real data, access to research scientists and faculty members. So hearing really interested in engaging cutting edge science talks. So I can't credit this program enough for really having an impact on myself and other educators in the field today. And that really opened the door for a lot of opportunities for me. So again, thanks to Kathy and her group, I became involved in a lot of curriculum development projects. The first one was writing a project-based curriculum for the Texas Water Development Board and their water exploration program. I also started reviewing Earth Labs modules and even facilitated a lot of professional development with the Earth Labs project. And I also got to do some field work, which was really exciting. So Jay Pulliam, who was at the Institute for Geophysics, had a project installing seismometers in West Texas and Eastern New Mexico, and myself and a handful of other high school teachers were involved in this project and traveled to Iris in New Mexico and learned all about seismology. And then finally, in my last few years teaching, Sean Gulick is here with us today. I had the honor and privilege of serving as an education officer on the JOIDES resolution for Expedition 341 to South Alaska. And from that, we developed a really interesting module for the Earth Labs collection using data from that expedition. So that, I would say, is probably definitely one of the highlights of my career so far. So really cool project there. So from there, I mentioned in my last year teaching, I taught the OnRamps geoscience class, and I was so inspired by the program, and really it kind of combined my love for geoscience education and working with educators and students that I switched over, came back to UT, and I am with OnRamps today. And I am having a hard time monitoring the chat. So if I'm not very good at multitasking when it comes to the chat. So if anyone wants to let me know if there's a question or something in there, I'm happy to answer those. So the mission of the OnRamps program is much aligned with the mission, some of the strategic missions of the Jackson School. And that is to increase the number and diversity of students who engage in learning experiences aligned with the expectations of leading research universities. And part of that mission, so this figure is one thing that really drives our work at OnRamps. So one of the most powerful drivers of low income or low persistence in graduation rates in college is the misalignment between academic expectations between high schools and college. So this figure is from the Texas Higher Education Coordinating Board. Nearly 40% of students don't meet one or more state college readiness standards. So those are, underrepresented in math, reading, and or writing. And so about 28 to 41% of those students go on to complete a college level course. And this is another figure from the Texas Higher Education Coordinating Board, just kind of showing the graphically a pathway of students. So out of 100 eighth graders in the fall of 2007, 78% of those graduated from a public high school in Texas, and 54% of those original 100 enrolled in higher education. So out of the original 100, 23 received a higher education degree or certificate, and you can see at the bottom the outcome of those. So only 17 of those received a bachelor's degree or higher. So at OnRamps, we are really working to help address this problem, and research has shown that dual credit students are twice as likely than students who have never taken a dual credit class to graduate in 4 years. And among those students who graduate in 4 years, dual credit students on average graduate 1 semester earlier compared to students with no prior college credit. And this is from some UT system dual credit studies that were done in 2018.
Can I ask a question?
Yes.
I don't have the hand raising since I'm a host. But by dual credit, what do you mean?
That's a good question. So I'm going to talk about, the OnRamps program is a dual enrollment program. Dual credit is what this study worked on. So that's when you have a college professor. A lot of community colleges offer dual credit courses where the community college professor either goes into the high school classroom and teaches the course, or students travel to the college campus, to the community college campus.
Got it. Thanks.
Mm-hmm. So what we have in the OnRamps program is we facilitate a network of Texas teachers and students, and we offer a sampling of intro level courses at UT for high school students. And I'm going to talk in just a minute about the geoscience course in particular. We also offer ongoing professional development and virtual support to our instructors. So in a couple weeks, we have our Fall Professional Learning Institute, where all of our instructors will join us through Zoom. And I also meet with my instructors virtually once a month to provide them with additional support. And these are the courses that OnRamps offers. We've grown considerably. I'll talk about our growth in a little bit, but we've grown considerably over the past several years. Of course, in my opinion, the geoscience course is the most exciting of them, but the science program is actually the largest program in terms of the number of courses. But we offer a variety of math courses. We have rhetoric, history, and computer science, and AET is art, entertainment, and technology. So the OnRamps Earth, Wind, and Fire course, this is actually a screenshot of our Canvas course, was developed and adapted from the Dig Texas blueprints, which were spearheaded by UTIG and Kathy Ellens and her group, an NSF-funded project in collaboration with UTEP and Texas A&M. But our course is really, of course, modeled after the residential Earth, Wind, and Fire course, but we have a lot more activities in the course to engage students in the high school experience. So really this course is, it aims to increase students' earth science literacy, and really modeled after the earth science literacy principles that were developed in part by the National Science Foundation. So our course has 6 units. We have an introductory unit to kind of on-ramp students to the college experience. And then we move from the solid earth and plate tectonics through geologic time and Earth's surface with a heavy focus on climate in the Earth's surface and oceans and climate unit. So I would, I really have to acknowledge my partner in crime here, who's I think out in the field today, but I work really closely with Dr. Joel Johnson, who is our faculty lead on the course. So Joel and I work together to make sure our courses are aligned, that students get kind of the most authentic college experience. We collaborate on assessments, and he kind of gives the seal of approval on course enhancements and everything that we do with the course. He's also very instrumental in teacher professional development, which I'll talk more about in a little bit. But Joel is our fearless faculty lead in the department. I kind of manage the curriculum side of things and work with instructors and our grading team. So I can't think, we would not be able to do this without our grading team. So we have Jackson School graduate and undergraduate students that help us provide feedback to student work. So I run calibrations with our student graders and manage that aspect of things. And then OnRamps also has a coaching team and a assistant director of science who really helps to keep us aligned with the OnRamps mission and support instructors. Okay, so I'm going to talk a little bit about our work with students in transforming learning in geoscience. So the great thing about the OnRamps courses is that students are exposed to these high-level, rigorous college courses with the safety net of being in their high school classroom. So the OnRamps courses are taught by or facilitated by high school instructors. So, you know, those high school instructors provide all the supports and reinforcements of students in their classroom setting. We also, since our course is modeled after the residential Earth, Wind, and Fire course, you know, students are exposed to that high-level college-aligned coursework. And so this graphic is kind of showing the difference between dual credit on the top and dual enrollment. A lot of people kind of get the two confused. Our program is a dual enrollment course, and the difference is that a dual credit course, which are often offered at community colleges, is taught by the college professor. Students take one class, so they might go to the community college campus and take that class, or the professor might travel to their high school campus, and the student receives one grade for the course overall. And that grade follows them on their transcript, regardless of what the grade is. The way the dual enrollment system works is that we have essentially 2 different grades, which is why, you know, we provide a nice safe entry level for college for these students. So students can get a separate grade for their high school course as they do for the college course. So the high school teachers often take a lot more grades and facilitate a lot more activities, whereas in the college side, we have a certain set of assignments that we take for the college grade. So 2 separate grades is key. Another thing about the dual enrollment course that's really nice for students is that students can accept or decline their credit at the end of the year. So let's say a student goes all the way through the year, they have a C in the course. At the end of the year in May, they can say, actually, I don't want this grade on my transcript, so I'm going to reject the credit. So they get the experience of college without having a transcript if they don't want it. All right, so I'm going to pause there. Does anyone have any questions so far? I know I'm kind of going a little bit fast through these intro slides.
I have a question.
Yes.
What grade are they in? Or that so it's like freshman, senior?
Mm-hmm. That's a really good question. So another thing about the dual enrollment portion, students for their high school credit get credit for Earth and Space Science in Texas. And typically students take that, it's a capstone Earth Science course that's taken in 12th grade, or some students take it in their junior year of high school. So we've got mostly 11th and 12th graders in our course. So for their high school credit, they get the credit for Earth and Space Science. For the college credit, they get a credit for Geo 302E, which is the Earth, Wind, and Fire course.
Very cool. Thanks.
Okay, so I'm going to talk a little bit about how we engage students in our course. And I'll start by asking you guys a little bit more audience participation here. So think about something that you know really well, and I want you to think about how you learned that thing or that skill. I'll give you a minute to think about it. Song lyrics. I like that, Dana, in the chat. So you can see if any of these choices match to what you are thinking of. And for this slide, you could use the annotate feature of Zoom if you would like, which you can access at the top of your screen. So if you click on the little annotate button, you can access the stamps up there and pick your favorite. I see people answering in the chat pod too, which is great. So in the chat pod, I see a lot of practice and learning by doing.
You know, I don't think that they have permission to annotate. Maybe they do.
I see some stamps there.
Perfect.
All right. So based on the chat pod responses and some of the stamps that I see, no one has chosen listening to a lecture, which shouldn't be all that surprising to us. So mostly practice and trial and error. Now I need to figure out how to erase these things. And actually, I don't know if I have the ability to erase. I might need your help with that, Naoma.
Let's see.
But that's okay. We can have a few check marks there.
Okay.
But yeah, so I also enjoy lectures, Dana, but yeah, so research shows that really students retain a lot more information from practice or trial and error. So really that's what we try to engage students with. So just like us, students learn best by doing, and when they're actively doing something and constructing their own knowledge and are engaged, that helps retain concepts. So one pedagogy that we use, and you can see kind of a list of our key pedagogies here and how we engage high school students in geoscience content. The first one is peer instruction. So peer instruction is a formal pedagogy that is championed by a Harvard physics professor, Eric Mazur, and essentially it makes lectures more interactive. So what we do is we embed concept test questions within our lectures. So we chunk lectures into 5 to 10 minute segments, and then we pose a question to students, and we first have them answer the question on their own independently, and then we pair them so that they talk to somebody, ideally somebody who has a different answer than they do. So they have to justify their reasoning and explain their answers. So we use a program called Learning Catalytics for this, just because it kind of has smart pairing option where it pairs students by their response. And really that causes students to really talk through some of these things. So when I was the high school instructor teaching, oftentimes I would tell my students to think, pair, share, talk to their neighbors about questions. And a lot of times it ended up being, what did you do last night? What'd you have for lunch? Just kind of chit chat. But the way that we, the systems we use to give students these questions really causes them to talk to people with differing ideas and defend their answers. And it really asks students to take risks in learning new content. So they might have to talk to somebody that they haven't talked to before. Another pedagogy we use in the course and is part of the college grade are concept sketches. And so I have an example of a concept sketch here of volcanic hazards sketch. And so concept sketches are really nice. We grade these with rubrics because they show us, what students know and what students don't, what students have misconceptions around right off the bat. So concept sketches allow us allow students to demonstrate their understanding of geological processes through these annotated sketches. And so Steve Reynolds is a huge proponent of concept sketches, and some of his papers on these topics really outline, the benefit to student learning through these types of assessments. So if we're asking students to demonstrate their knowledge by annotating and describing processes and interactions, it helps students understand things at a deeper level if they're explaining this to somebody else. Looking at a student sketch really helps us quickly understand what students know and also their misconceptions. And spatial thinking skills are always a challenge for teaching, especially at the high school level. So this helps us to develop students' spatial thinking skills throughout the year. So over the course of our year, students do 10 different concept sketches. And then the last type of assignment that we take for college grade are lab activities. So all of our labs, and as I mentioned before, a lot of our course was developed using the Dig Texas blueprints. So we use a lot of activities that use real world data and focus on data analysis. So students are gaining some skills in their science literacy. A lot of our labs incorporate spreadsheet skills. So students graph, analyze data using Google Sheets or Excel. And the list I have here are just some of the types of examples of lab activities that students would use a spreadsheet program for. So modeling seafloor spreading with Excel or Google Sheets, analyzing the data that comes from the Mauna Loa Observatory. So we look at CO2 data and project that data. We look at ice core data, and we have a really neat activity that Joel Johnson and I actually presented at an AGU gift workshop a few years ago, where students take historic flood data from the Trinity River in Grand Prairie and make a flood hazard map from that data. So a lot of useful skills. You know, at the beginning of the year, students struggle with the spreadsheets, but by the end of the year, and when they get to college, they know a lot more about how to use spreadsheet programs than most of their peers. We also really work to on-ramp students to the college course. So before they start any of the college units, we have some kind of orientation units that give them a taste of the different types of college assignments that they'll be exposed to, including an orientation. So OnRamps has an orientation course that students go through that teaches them about, you know, academic integrity and the academic integrity policy of the University of Texas. Growth mindset is something that we infuse throughout the year, and other learning strategies. So we really kind of weave metacognitive learning strategies throughout the year to help students, you know, kind of understand the skills that will help them become better learners and help them prepare for college. And then, so I'm going to talk a little bit about how we prepare our high school instructors to teach our courses. So our high school instructors are really the backbone of our program. And we plan professional development institutes that really help instructors learn from each other and grow throughout the years. So we do this by deepening their content knowledge for 2 weeks over the summer. So all new instructors come to UT Austin for 2 weeks in the summer. Returning instructors come for a shorter institute to kind of go deeper into their teaching practice and build their content. And we also offer field trips in the summer and then in either the spring or fall traditionally. And during the 2-week institute, when instructors come to UT, it's a really intensive summer training. Teachers do kind of a model teach lesson where they practice delivering peer instruction and some of the pedagogies that they'll be using with their students. They work through a lot of as much of the curriculum as we can, and then we're really Dr. Johnson is providing a lot of the science content that they need throughout the year. And then we follow up every fall and spring with some deepening of their content knowledge. Other things that we do with our teachers throughout the year, our teachers engage in virtual coaching. So we use kind of a virtual coaching platform called SIDME, and they record themselves teaching, and they learn from each other in this virtual community of practice. And here are just a couple shots of our instructors hard at work at UT in not this past summer, of course, but in summers past. So on the left, you can see Dr. Johnson taking the instructors through a geologic field trip of the building stones of campus. And then on the right, you can see instructors looking at some seismic data to learn more about the Earth's interior. So we really do have them working. They work really hard throughout the 2 weeks that they're here with us. And then, of course, this last summer, our instructors engaged in a virtual professional learning for 2 weeks. And so I really have to give my instructors so much credit because they are working tirelessly for their students and do so throughout the summer. Another great thing about our program, and this is one of the most popular things, especially for our instructors who have been with us for several years, because field trips really help to deepen their content knowledge. Joel is really great about taking our instructors on field trips. So we try to find different locations to take them around Central Texas. On the left, We're at an area near Longhorn Dam in East Austin, where there's been some pretty significant erosion problems. And then on the right, this is a field trip we did last year to the Canyon Lake Gorge. And then I have so much appreciation for the Jackson School community because every time I ask for a guest speaker or something like that, people are always so willing and excited to talk to our instructors. So our instructors have learned so much from so many different faculty members and research scientists. On the top left, this is Dr. Martindale presenting her taphonomy game to our instructors last fall. Dana Thomas, who's here, thank you, Dana, worked with Nicola Tisado to engage our instructors in an Arduino workshop. This is a model volcano down here on the left where they programmed Arduinos and got to learn about volcanic eruptions and the kind of morphology of volcanoes. Dr. Michael Young talked to us about Planet Texas, and that was from last year as well. And then a huge shout out, I think I saw Dr. Catania come into the room earlier, but she was one of the faculty members who helped us with a video series to in our course to help students understand what geoscientists do and some of the things that some of the career paths and research projects that geoscientists are working on. So we filmed a series of videos, one to complement each unit of study in our course. And this is Daniela Rampi on the top here, but Dr. Catania helped with those too. So we love learning from the Jackson School community. Our teachers really, really appreciate that. Okay, so finally, I'm going to talk to you about some of the impact that our program has had since the 2015-2016 school year. So this first graphic is showing the growth of the OnRamps program as a whole. So OnRamps started in the 2012-2013 school year with a computer science course, and you can see has grown exponentially over the years. So in the 1920 school year, we had over 33,000 student enrollments. So a huge operation that we're running here from UT Austin. And I should also say that we do partner also with Texas Tech University. Texas Tech is replicating the geoscience course. So there are about a little over 100 students in the Lubbock area taking the Earth, Wind, and Fire course through Texas Tech. In terms of how the OnRamps Earth, Wind, and Fire course has grown, this shows, so the Earth, Wind, and Fire course started in the 2015-2016 school year. And in this pilot year, we started with 226 students and 7 educators, all based in the Austin area, so Austin and Round Rock primarily. And I think maybe, and then Lubbock was also part of this initial pilot. And so this year we've grown, over the years we've grown considerably. So this year we have a little over 1,500 students. I work with 63 educators who are on 62 different high school campuses across the state of Texas. So all of these numbers, all of these teachers are in Texas. So we're partnering for the geoscience course with 44 districts across the state. And this is a video that I don't think is working, but this kind of just shows you color-coded as another visual where where our teachers are located around the state. So we've got a cluster of teachers in the El Paso area in West Texas. The DFW area is another hotspot. And then of course, Austin and San Antonio. And then in recent years, we've really been reaching out to a lot of the smaller districts in Texas, which is great that we're able to offer our courses to students from really small districts. And then to show you a little bit more about our demographics, and this is for the OnRamps Earth, Wind, and Fire course from last year. 57% of our students, and these are self-identified numbers from a beginning of course survey, 57% of our students identify as Latino, 26% are white, and then 12% African American, and then 4% multiracial and Asian descent. And then you can see a little over half of our students identify as first generation college students. So we're really targeting a diverse population with our program. And then our gender breakdown, a little over half of our students are female, and these are last year's numbers, but on average it's pretty similar from year to year. So a little half of our students are female, which is 15% above the undergrad geoscience population. And then to compare those numbers to UT Austin. So here you can see the OnRamps geoscience demographics. And this data was pulled by Dr. Johnson in a presentation we gave over the summer, but compared to geoscience undergrads at UT Austin, 18% identify as Hispanic, and then undergrads at UT Austin in the fall of 2019. So we're really targeting a diverse population with the OnRamps geoscience program. So how many students receive college credit? In 2019, 2020, 72% of our students were eligible for the opportunity to earn college credit. So basically what we look at, if students go in to take a dual credit course, they have to meet certain college readiness standards. For our course, we use their fall semester grade to determine if they're college ready or not. So that tells us if they can continue in the class for the opportunity to earn college credit. So that's what this 72% is right here. So regardless of whether they meet that fall semester grade cutoff or not, all students stay in the course. We don't differentiate them at all. But 72% of students that start the class in the fall are eligible to earn college credit in the spring semester. So out of those 72%, 90% of those eligible actually earn college credit. And so when we're saying earn college credit, that means they receive a D or higher. So 90% of students earn a D or higher in college course. And out of those, 82%, so earlier I mentioned that students can accept or decline the credit at the end of the year. So 82% of the students go on to accept the college credit. So a lot of the students who might have a D or a C would probably reject the credit, but 82% of those that earn college credit for our course last year accepted it. So that's a pretty significant percentage. We think 90% earning college credit over the course of the year. So since the OnRamps Geoscience program started in 2015, 2016, we've awarded over 5,600 semester credit hours to geoscience students. And those students go on to attend colleges in Texas and then across the country. This figure is a little bit outdated, but this is showing where OnRamps students attended college in the 2015-2016 school year. Just like AP courses, the OnRamps credits are guaranteed to transfer to any public Texas or university. And then they also transfer to many out-of-state schools, but students have to contact admissions offices to find out if the credits transfer, just like an AP course. And finally, so we also give students some end of course survey questions to ask them about their experiences in the geoscience course. So you can see that on the left here, a lot of students, or a large percentage of students, were not familiar with the field of geosciences before taking OnRamps Geoscience, which is probably not a big surprise to us. So, you know, really one of our goals is to make students aware of geoscience, not only making them climate or geoscience literate students, but also showing them that this is something they could pursue in college. And then we hope to give them the skills to do well in future science courses. And then the figure on the right, of course, we would like to see this go up and having students become more interested in taking more geoscience courses in the future as a result. And I wonder how, you know, these numbers would compare to students who might take an intro level geoscience course on campus. But, you know, we are getting a fair number of students who are inspired and interested to go on to take more classes in the future. And then this is kind of one of my final inspirational slides. So I always love it when we hear back from students in whatever way, social media or otherwise. But, you know, this is at the heart of what we do. We really aim to prepare students for college. And then, of course, a huge bonus if we hook them and kind of pull them over to studying geoscience. But that's it. And then I want to credit again the Dig Texas program and their collaborators for their work and inspiring the OnRamps Geoscience course. And I am happy to take any questions if anyone has them.
Looks like we've got a question in the chat from Dana. It says, do you know how many go on to take more geoscience courses or perhaps even major in geoscience?
Yeah, Dana, that is a great question. That is something that is data that we hope to gather, but at this point we don't have any data on students pursuing geoscience beyond our course. Yes. Yeah, I would love to talk to you about that.
Other questions, folks can feel free to unmute themselves and call it out, raise your hand, or put it into the chat. I was curious, is there any sort of interaction or overlap with Geoforce? Do you guys have any of the same students ever? How does that work?
You know, that's one of our goals as well, is to align with the Geoforce program to really target those campuses. We have a cohort at Aikens High School who are in the Geoforce program, but yeah, that's something that we're also wanting to pursue. Basically, the way the OnRamps program works from an organizational level, we have a partnership team that, you know, kind of goes out and recruits at the district level. So a lot of it is kind of above where I am. I'm not quite involved with the recruiting aspect of things, but we definitely want to synergize the Geoforce and OnRamps programs because they go hand in hand. When we do have Geoforce students in the course, you know, it's amazing to see how they apply what they've learned in the Geoforce program. So I really see it as kind of like a capstone for their experience in Geoforce.
Awesome. We have another question in the chat from Dana. It says, has Joel changed his college level course as a result of working with high school educators?
Yes, that's a really good question. It's too bad Joel is not here to answer that question. But he has, and he, you know, Joel is great. He's great at working with our high school instructors, and he's very transparent and open. But he will fully admit that his teaching has evolved as a result of his participation with the OnRamps program. You know, one example of, you know, he uses clickers and has implemented the peer instruction in his Earth, Wind, and Fire course as one example. But we also, every year we make improvements to our course. So another thing that we've done every year is tried to align our courses more and more. And I see a question from Sam.
Yeah, Sam says, do you know if OnRamps / Office of Strategic Planning has thought about talking with the College Board about an AP Geo course based on Earth, Wind, and Fire?
Sam, I don't think that they have. That is an interesting idea. I know, part of the strategic plan for OnRamps over the next 3 years is to broaden our strategic partnerships. And I know there's a lot of, national interest in dual enrollment or, higher college level courses for geoscience. I'm not sure if AP is on that list of partnerships or not. But I would love to see the geoscience course, expanded more in some way.
I have another question. I imagine how you guys had to adapt this year with courses being online for COVID?
So, in the spring, our instructors gave us a lot of feedback that this was the easiest class for them to transition to, mainly because all of our curriculum is delivered through Canvas. Students submit all of their work through Canvas. But we have, that being said, we have adapted our curriculum to help instructors who are engaging students asynchronously or in a hybrid environment. So we have spent a fair amount of work at the beginning of this year, kind of adapting to all of the different learning modalities and also training our teachers on these things.
Looks like we have a question from Dana. It says, unless I'm mistaken, is it true that Earth, Wind, and Fire doesn't count as a physical geology requirement? Could you say a bit about that?
Yes. So our course, just like the residential Earth, Wind, and Fire course, counts as a science credit for non-majors. So a student who is interested in pursuing a degree in geoscience would not get a science credit or wouldn't get a physical geology credit for our course. I think, does that answer your question, Dana? Okay, yeah. And Dr. Kyle is here. I have to give a special hello to Dr. Kyle. He was my master's advisor when I was in the Jackson School. Hi, Dr. Kyle. It's good to see your virtual presence.
Dana says, as a follow-up, I wondered what you thought about that.
I think it would help us, recruit perhaps more students to pursuing degrees in geosciences. But I also think that we would need to modify our curriculum to be more suited towards the physical geology content. Because really, I would say that our course has kind of more of a focus on environmental literacy, environmental geology, rather than kind of the physical geology component. But I do think that it would help, recruit more students to pursuing degrees in geosciences. An EVS option? Yeah, potentially. I would love to see more earth science related courses in the OnRamps program.
Yeah, I was thinking about that environmental science as well, because my experience is a little different since I'm more familiar with the way that public school works in California. But in California, like most people that are taking geoscience are freshmen, and they're taking geoscience because they're like, quote unquote, not on the college track. And then everyone who's on the college track takes biology. And then, senior year, they might take like environmental science, but no one's taking taking like a geology course unless if they've been like, in my opinion, kind of unfairly shunted on this path. So I don't know if it's similar to
Right.
Texas or not, but I think that's kind of a challenge for geology as well.
Yes. Um, it's very similar in Texas. So most students who are on, the college going path would take AP chemistry, AP physics, AP biology, which is something that was happening, with the Earth and Space Science course when it was developed. It was developed to be this capstone, rigorous science course, and in most schools, that's not what it became. It became kind of the course for students who didn't like science or weren't on that college going track. And even with the OnRamps course, we see a lot of students who might not normally take a college level course, which in my opinion is great. And that's the mission of our program. I love that we get those students, but there's still, I think there's still a perception out there that the geoscience course is for students who might not be as excited about science as other students. And then I see a question in there from Rich Ketchum. Hi, Rich. Do we anticipate continued exponential growth in the EWF course? So our growth has kind of flattened out a little bit compared to some of the other courses. Like, physics grew exponentially. I think the physics course has a little over 5,000 students in it right now. The chemistry course, which is in its second, I think, year, has more students than we do, closer to 3,000 students. So, I think kind of what we were just talking about, that a lot of districts don't perceive geoscience as a course that students really need or will help them in college. I feel like it's a little bit harder to get our course to grow as much as some of the other courses. But I do anticipate that we'll continue to grow, but probably not at an exponential rate. So I think, and now also students pay for our courses, which is something that I didn't mention, kind of the funding. But when OnRamps started, we had an appropriation, or we still have an appropriation from the state. When OnRamps started, students didn't have to pay for our courses. And now our courses are subsidized by our appropriation, but students or districts are charged $150 to $99, depending on if students qualify for free or reduced lunch. So now that students have to pay, we've seen the numbers go down a little bit, but they're still growing slightly. Oh, and then Leah. But yeah, most of the districts in terms of funding, most of the districts cover the cost of their students. But we do have some areas, charter schools and private schools, where students do pay for the cost of the course, which compared to what they would pay at UT is a huge deal, but it's not insignificant by any means. Rich, I hope you were here for my CT Lab shout out. You'll have to watch the recording.
All right. Well, if there are no other questions, thank you so much, Alison. This was a really fun talk. I really
Thank you for having me.
Yeah.
I enjoyed it.
All right. Thanks, everyone. We'll see you next week for
Thank you.
Gomez. Bye-bye.